Algebra 3, lesson 33, lesson 34. For the lesson 33 stuff, most of this is found in your book. So you can do a little bit of reading here. Basically, we're talking about properties of parallelograms, quadrilaterals, types of parallelograms, conditions for parallelograms, and conditions for trapezoids. So I'm just going to do some quick reading here. You have quadrilaterals, you have trapezoids, parallelograms, and then what are called trapeziums. Trapeziums aren't anything in specific. They don't fit any of the rules. Okay, they break the rules. They're like the bad boys of the quadrilaterals. Okay, if you can imagine like a whole gang of motorcycle riding quadrilaterals, we would call them the trapezium gang. So we appreciate that. Trapezoids have a certain set of rules. Parallelograms obey some rules. Trapeziums make their own rules. Nobody else's. They don't even follow their own rules. All right, so we get down to parallelograms and what those rules are. You have 4 rules. We covered this stuff in geometry. Both pairs of opposite sides are congruent. Hopefully I don't need to draw pictures of this. Do I need to draw pictures of this? Would that help? No? Okay. Both pairs of opposite angles are congruent. We understand what opposite angles are. They're congruent. Do we know what consecutive angles are? Consecutive angles are any 2 angles in a quadrilateral that are not opposite. All right, so any 2 angles that share a common side are going to be consecutive angles, and they're going to be supplementary. Supplementary 180. If we get the headphones out, I just want to make sure that you hear me and you're not listening to something else. Okay, because I'm going to give a lot of information really, really quickly. Finally, let's see, in the diagonals bisect. Bisect means to cut into 2 congruent halves. All right, the diagonals of a parallelogram are not necessarily congruent to each other, but the individual halves of a diagonal line are congruent to each other. Does that make sense? Okay, and those are split into where those 2 diagonals cross, so they'll bisect each other. Okay, let's see. You can see properties of rectangles, properties of rhombuses, properties of squares. Now I'll say this about squares. Squares contain all the properties of rectangles and all the properties of rhombuses. A square is only a square if it is a rhombus and a rectangle. Okay? All squares are rectangles, all squares are rhombuses, not all rhombuses are squares, not all rectangles are squares. Does that make sense? All right, so what we know about rectangles is that all of the rules for a parallelogram apply. So those 4 rules that we just talked about, all of those things are true of rectangles, but rectangles have some specifics. All 4 angles of a rectangle are congruent. They're all going to be right angles. All property in the diagonals are congruent. So those are the 2 new things. All angles are right angles, and the diagonals are actually congruent to each other. So those opposite lines are equal to each other. Then we get into rhombuses. Rhombuses, all 4 sides are congruent to each other. All the rules for a parallelogram apply. So those 4 rules that we talked about at the beginning are all true. The diagonals are not congruent necessarily, but they are perpendicular to each other. Okay, so they'll form a right angle whenever they cross. So with a rhombus, what we wind up with on the inside of a rhombus is 4 right triangles. Okay, so that becomes significant later on. The diagonals still bisect. The diagonals bisect the angles whose vertices they connect. So where that diagonal line meets the vertex of the rhombus, that angle is bisected, okay, in those 4 places. All right, and the intersecting diagonals divide the rhombus into 4 congruent right triangles, which we already covered. And then a square has all the properties of a parallelogram, has all the properties of a rectangle, has all the properties of a rhombus, and the diagonals form 4 congruent isosceles right triangles. So just like how a rhombus has 4 right triangles inside of it, a square has 4 right triangles inside of it, but more specifically, those right triangles that a rhombus has are isosceles right triangles. So every right triangle inside a square is a 45, 45, 90 right triangle, which makes it a lot easier for us to solve for different parts of a square when I know it's a square. All right, so do we understand all of that? We have conditions for parallelograms. You find those on page 236, conditions for a quadrilateral to be a rectangle, properties of trapezoids. Let's look at trapezoids on page 237. We should know how to find the area of a trapezoid is base 1 plus base 2 times height divided by 2. Area of a rectangle is length times width. Area of a parallelogram is base times height. Area of a square is side squared. Okay, we get all of that. Okay. You do have a couple of different types of trapezoids. You look at the bottom of page 237, the area of a trapezoid is what we've already talked about. The median of a trapezoid is parallel to its bases. And its length is 1/2 the sum of the lengths of its bases. So I would say base 1 plus base 2 divided by 2 is going to be the median of the trapezoid. Do we follow that? We're looking at pictures on page 237 to see that. All right, then you get properties of isosceles trapezoids, which is different than different types of trapezoids. So you might see a trapezoid that looks like this, okay, which is different than a trapezoid that looks like this, where I know that those two sides are congruent to each other. So the one on the right is isosceles, the one on the left is obviously not. They're different types. In an isosceles trapezoid, like what you see there on the right, the lower base angles are congruent. So if I know that this is isosceles, then I know that those two angles are congruent to each other. All right. Let's see. The upper base angles are congruent. So then I also know that these angles are congruent to each other the moment I know that's an isosceles trapezoid. The diagonals are congruent. So this line is equal to that line. Okay? And any lower base angle is supplementary to any upper base angle. So these two angles right here add up to 180. Okay, same way over here. Add up to 180. Okay, so you got a lot of stuff in your book there that you're going to be able to use to solve for different things. I'm going to go ahead and shoot over to lesson 34. We're going to talk about summation notation, linear regression, decomposing functions. Before we get into that, let's go ahead and try to answer some of these questions that we see up here. Okay, because I got about 20 minutes to answer a lot of different questions. Okay. All right, so identify the quadrilateral which has two pairs of parallel sides and all angles are congruent. Two pairs of parallel sides. That would be and it says, and all angles are congruent. The hint there is all angles being congruent would make that a rectangle, because a rhombus doesn't necessarily have all angles congruent. And you can't, you could probably, which has two pairs of parallel sides and all angles congruent, you could say a square, but a square is a rectangle. So we want to be more general and say rectangle, okay? Question number 2, select a geometric figure that possesses all the following characteristics. It's a polygon, it's a quadrilateral, two and only two sides are parallel. What is that? Two and only two sides are parallel. That's the important part. So is it a parallelogram? It's a trapezoid, okay? Because a rhombus, a parallelogram, and a rectangle have two pairs of parallel sides, right? We only want one pair of parallel sides. That's going to be a trapezoid. Let's see. We're going to skip number 3 for sake of time, okay? Number 4, we might come back to it if I get through everything. Number 4, all angles of certain parallelograms are equal. Of a parallelogram are equal. Which of the following could the parallelogram be? It could be a square. It could be a rectangle. Okay, those are the only two it could be, because a rhombus only has all angles congruent when it is a square. Okay, and only when it's a square, because the square is a rectangle. Okay, so we would stick with square and rectangle. Do these answers make sense? I know I'm talking fast, but 2 lessons today. So number 5, all angles of a certain parallelogram are equal. Which of the following best describes a parallelogram? Is it a square, quadrilateral, trapezoid, or rhombus? Trapezoid has all angles congruent? No. Do all quadrilaterals have all angles congruent? It'd have to be a square, because the other 3 don't fit it at all. If rectangle was on there, we probably would have gone with that. Okay. Number 6, given a quadrilateral with all pairs of consecutive angles being supplementary, okay, which of the following must be true? The diagonals form right angles, the diagonals bisect each other, or all sides have the same length. All right, well, when are the, let's see, all pairs of consecutive angles are supplementary. When are those consecutive angles going to be supplementary? Well, what shape? What shape has consecutive angles being supplementary? Any parallelogram, right? Okay. So given a quadrilateral with all pairs of consecutive angles being supplementary, which of the following has to be true? Well, the diagonals would bisect each other, right? Because that's true of all parallelograms. Okay? It's also true in trapezoids, but it's only true in one type of trapezoid, and that is a isosceles trapezoid. And even in an isosceles trapezoid, the diagonals are congruent, and so they would bisect each other. Does that make sense? So it would still be true even with that specific type of trapezoid. It's a trapezoid that has two sides congruent. Okay, but it's going to be the two sides that are not the bases. Okay, because the bases of a trapezoid are never congruent. Okay, does that make sense? Let's see, 7, given a parallelogram whose diagonals are perpendicular, you automatically ought to think rhombus. Okay, which of the following must be true? So I'm looking for rules that are specific to rhombuses or rhombi. Okay, the diagonals are of equal length. That's not true of a rhombus necessarily. All sides are equal and all angles are right angles. The part that says all angles are right angles is not necessarily true of a rhombus. All sides have the same length. That is true of a rhombus. All angles are right angles. That's not necessarily true of a rhombus. We would end up with C as an option because that's specific to rhombuses. Does that make sense? Okay. Did I go way too fast for anybody through there? All right. I think we have another page in here that's going to deal with midpoints of trapezoids or mid-segments. What they told you about mid-segments is that the mid-segment is half the sum of the bases. So if I look at this length right here, median, EF, in the figure EF is the median of trapezoid ABCD, find X. So what we're going to do here is we're going to say 3x plus 2 plus 6x plus 4 divided by 2 equals 5x plus 3. Okay, it looks a little bit like your midpoint formula, right? And if you remember from geometry where we knew the midpoint, right, and we had to solve for the other endpoint, it's kind of like that. We're going to multiply by 2, which means I'm going to distribute the 2. And then I'm going to combine like terms. So 3x plus 6x is 9x. 2 plus 4 is 6. And I'm going to distribute the 2 and get 10x plus 6. All right, subtract 9x because we're just trying to solve for x. Minus 9x. We're going to subtract 6 on both. 6's cancel, which means I wind up with 0, right? 0 equals what, 1x? So x equals 0 in this case. That's fine because let's go ahead and check it. What's 3 times 0? Okay, plus 2. So I get 2 there. What's 6 times 0? So I get 4. What's 5 times 0? Plus 3. So what's 2 plus 4? What's 6 divided by 2? Does it still work? So x equals 0 is a possible solution, right? All right, you would do the same thing on number 9 that we just did there. All right, and the answer that you would get would be 1. Okay, so you're going to take 3x minus 1 plus 6x minus 4 divided by 2 equals 4x minus 2. Multiply by 2 on both sides, combine like terms on the left. Right, solve for x equals 1. Okay, all right, so we're good there. All right, let's get over to lesson 34. We'll talk about summation notation. Let me see, I'll find it here. All right, summation notation. Your newer calculators that look like this will do this. Your older calculators, you'll have to do this by hand. All right, so summation. That's what this symbol right here means. That Greek letter sigma just means summation. Okay, so I believe what it says here is that we have 9 summation. It should be k equals 4, and then it gives me an equation here of 1/3 Okay, now these will get more complicated as we go. What I'm going to do is I'm going to go ahead and move over here here we go. All right, so let me show you how these parts work. They're not hard. Okay, but sum, what does sum mean? Add, okay? So what this tells me is that I'm going to start, my minimum is the number 4, my maximum is the number 9, okay? Then I'm going to plug in the minimum, right? So I got 1/3 to the 4th. That's my first one. And I'm going to go by integers all the way up to the maximum. So plus 1/3 to the what? What's after 4? It should not take us that long to add 1 to 4. 5, all right? Plus 1/3 to the 6th, plus 1/3 to the 7th, plus 1/3, 8th, plus 1/3 to the 9th. Okay, so you can do that. I can't actually show you on the board how to do this in your calculator because I have an old emulator. So, but we can go ahead and do this in a sense because 1 to the 4th is 1, right? 3 to the 4th is probably a pretty large number. What is that? Is that 60? No, 81. So we got 1 to the 81st plus 1 to the, you're going to multiply that by, you're going to get bigger and bigger numbers, right? All right. So in the end, what did you say? 243? So I'm going through this. Now, could I plug all of this in my calculator just like this? Sure. Do I want to use parentheses? Yeah, I want to use parentheses through there. I should, in the end, get a decimal of 0.018. All right. If I plug that in my calculator to get a fraction, 0.018 has a fraction of 9/500. Okay, so that's the answer that I should get for that question. Okay? Go ahead. It would be x equals 4. And so the place to find this, if you have a newer calculator, is you go to math. Yeah, the something something. It should be number 10 or what's directly after 9. It'll say summation, you'll hit enter, and then you'll hit x for your variable. You hit 4, you can go up and plug in 9. Inside the parentheses, I'm going to write 1 divided by 3. On the outside, I'm going to hit the caret symbol, and I'm going to hit x again. Okay, does that make sense? Let's see, for some reason it gives me 1,024. Yeah. Huh. And that's what I got there. So and I've had that problem. I think that we've had problems with our graphing calculators getting this. Has anybody actually gone through and plugged all of this in their calculator yet? Because there's no way we should get 1,024, right? Because all of these are really small fractions. I shouldn't be getting a huge number there. Shouldn't, no. So I'm curious as to what the issue is with the calculator on these. That's why I'm telling you, you're better off sometimes to do it pencil paper. Okay? But I do want somebody to go through and check and make sure that we get 9 out of 5. You got the 0.018? Okay, good. Okay. All right, so the next one, right, as you look, effectively it's the same thing. I wish they mixed it up a little bit, but you can see that your minimum is 2, so you're going to start off with 1/3 squared, and you're going to go plus 1/3 to the 3rd, plus 1/3 to the 4th, plus 1/3 to the 5th, plus 1/3 to the 6th, and that's where I want to stop. But you do need to remember, because it's summation, we are adding these different sets. Okay? We're not multiplying them, not dividing them, we're adding every time because it is summation notation. Does that make sense? Okay. This last part in here involves using our graphing calculators. The first we're talking about here is linear regression. Okay. And the most important part that you want to figure out with this is that what you want to do, you want to figure out what your x value is and what your y value is. In this case, you want to look at the equation that they're giving you. All right. So you can tell from here that c is my y, okay, and a is my x. Okay, you follow me? Okay. So if I go into my graphing calculator, right, we're going to do probably just maybe one of these. Let's see. There is, you could go through and you could go into your list, stat list, edit, and get your x and y values. X should be list 1, y should be list 2, but I'm going to show you how to do this without a calculator. Looking at the graph, what we'd want to do is we want to find our slope and y-intercept. Okay, our y-intercept is pretty easy to see here. It's at 600. What they're asking for is they want to know the equation in slope-intercept form. So what I'm looking for is I'm going to look for two coordinates where it crosses, and usually that's happening at two pretty obvious places. For one, it's happening at, and I need to look at my scale here, but it's happening at 0, 600. And I think the other place that I've picked out here is 100 and 1,000. So if I look at 100 and I come over to 1,000, 100, 1,000, right? Now I'm going to use my point slope formula. So I'm going to use 1,000 minus 600 over 100 minus 0, right? I'm getting what, 400 minus 400 over 100, which is giving me a slope of 4. So in the end, my equation is C equals 4A plus 600. Okay? But if you set this all up in your graphing calculator with all of those points, right, and I had all that data, I could go to stat, I could go to calc, and I could go to one variable statistics, and it would, if I scroll down, it would give me the y equals mx plus b formula. It might be a little different than this, but this is, I think this is maybe a little bit quicker doing it pencil paper than it is plugging in all the data sets. So if we see a question like this on a test, you can ask me, hey, what two coordinates can I use for this? And I'll tell you, okay, because sometimes the pictures are pretty poor. Okay, do we follow all that? Okay. Finally, we're looking at 5, 6, and 7. It says find two functions such that f of g of x equals 4 over x squared minus 8. Okay. This is what we call decomposition functions. This is where we're trying to split the functions apart. Okay? Where we have f of g of x. So let me get over here. F of g of x equals, what we have here is 4 over x squared minus 8. So what we're saying is that g has gone inside of f, okay? So typically we have f of x and we have g of x, find f of g of x, and that's where we're plugging all of function g into the x value of function f, right? Okay, this is decomposition of that. So what we should see here, hopefully you understand this, is that the function f of x is f over x, or sorry, 4 over x, and g of x would then be x squared minus 8. Do we see how if I plug g of x into f, I would replace x with x squared minus 8? So the division bar becomes my grouping symbol. Did that make any sense? Okay. Let's look at another one. Let's look at the next one. It says find f where g of x is x squared plus 9 and f of g of x is x squared plus 9 squared. So g of, let's see. They tell me g of x equals x squared plus 9. F of g of x is x squared plus 9 squared. So f of x would have to be x squared, because what you can see is g of x has been plugged in. So what I'm doing is if I just simply do away with the parentheses and replace it back with x, I would get f of x equals x squared. So if you remember whenever we tried to put things inside, I said make a set of parentheses where the x used to be and then fit the other function in. Here, I'm taking out the parentheses and putting x in where that parentheses was. Okay? One more, just so that we've done it. Okay, I think I've got time, which is number 7. Find f. We got g of x equals x cubed plus 7. Is this the same? Well, it's kind of similar. F of g of x equals the cube root of x cubed plus 7. Okay, so what is f of x then? What would f of x have to be? Notice that g of x is right here, correct? So let's say I did away with that. What would I put in its place? I would get the cube root of x. So all I'm doing is I'm replacing the other function with x to get the other function, right? I'm replacing g of x with x to get f of x. Does that make it a little easier? If I just take out g of x, replace it with x, that's going to give me f of x. That's what we're talking about with decomposition. All right, that should be fairly easy. Hopefully we understand all that. Just questions from lesson 34. Don't make this mistake of doing lesson 33 questions, right? Christian, I'm still talking, so you keep that out. Otherwise, I'm going to start getting ticked off. Okay? Does that make sense? Nobody's grades are in here are so great that you don't have to listen to me. Okay? So I'm going to hit pause on this.